guys, so let's get into Uranus. Alright, that's the last joke I'll do, I promise. You guys loved this book. And so do I. So, let's find Uranus. A world on its side. Page 187. Here we go. There's Venus. Okay. 187, 173. There's Saturn. 187. Almost there. And here we are. We have arrived at Uranus. That was a pretty quick trip. As if twisted by a great cosmic hand. Uranus spins on a tipped-over axis for 42 Earth years. One pole is bathed in sunlight. While darkness envelops the other. Once the planet has moved halfway around its orbit, the other pole will be aimed sunward for just as long. Voyager 2. Scientists working with the Voyager 2 spacecraft determined that for some unknown reason the dark pole is slightly warmer than the sunlit pole. Uranus is so far from the sun, 19 times the distance of Earth, which we call astronomical units, 93 million miles. instead of at a 45 degree oblique angle, it's a vertical 90-degree angle, at least from the horizontal. It's assigned for the metal platinum. Here we can see the position relative to the other orbits of the planets in our solar system here. It's the second to last planet, although I think this book is old enough to where it's still considered Pluto a regular planet. It has Saturn, then Jupiter, then the asteroid belt, and then the 4 terrestrial planets inside that, in between it and the sun. So like a lazy green giant with 15 gray dwarfs, Uranus and its moons tour our solar system on their sides. Because as you might imagine, you can imagine that the objects revolving around the axis of rotation for Uranus rotates like that. The moons would also follow that rotation and would lie in that orbital plane, as they call it. So as the planet orbits the sun, its tipped-over axis stays aimed in the same direction, just as your foot keeps pointing forward on a revolving bicycle pedal. So as it goes around the sun, it looks like this as it orbits the sun. So, if this is the axis of rotation, we'll pretend this logo is at the equator, then it remains as it orbits the sun. The North Pole remains facing the same direction. You might think of it as constellations, whatever constellations are to this direction of our sun, of our solar system. The North Pole faces that. So unlike our Earth, which rotates with its poles facing upward out of our solar system constantly with a slight 26,000-year wobble, Uranus faces directly along the orbital plane of our solar system, its north and south poles, which is interesting, definitely interesting. This racquetball actually makes really good sounds. I'll save that for another video though. So here, you see the sun above the South Pole. Uranus spins with one side an endless day and the other an endless night. But when Uranus reaches the top of our diagram, giving day and night from the pole to pole, from pole to pole. No, sunlight strikes it sideways. I read that wrong. It's closest to the type of daylight that we would receive. It's only roughly maybe a third of the time together. I mean, maybe half if you're really averaging it, I guess. The day these somewhat resemble the patterns of night and day along the equator of Earth. In a quarter orbit later, only the northern hemisphere then would see light. So Uranus ranks third largest of the four gas giants. It's more massive than 14 Earths. Light gases and ice form so much of Uranus that the planet is only 1/5 denser than water. That makes gravity at the cloud tops surprisingly weak, about 9/10. So not quite as strong as Earth's strength, gravity. A peekaboo star. A peekaboo star led to the discovery of some of Uranus's rings from the Earth. As we peeked through it, it made the glimmer. The starlight was obscured by the rings of Uranus. In 1977, Uranus was due to pass in front of a faint star, and scientists aimed their telescopes to watch. As the space between the planet and the star grew smaller, the star seemed to flicker 5 times. Then Uranus covered it, and when the star reappeared again, the starlight flickered 5 times before leaving the vicinity, the veil of Uranus. And then as Voyager passed, it found at least a dozen others. So the length of the year is 84 Earth years. The average orbital speed is 6.8 kilometers per second, and the average distance from the Sun is 2 million, actually almost 2.8 million kilometers. No, that's not right. 2.8 billion kilometers. Sorry, guys. Sorry, Carl Sagan. Length of day is 17 hours retrograde rotation. And axis tilt like ours is 23 degrees or something. Uranus is 82 degrees. So its rings are 1 to 100 kilometers wide. Its diameter is about 50,000 kilometers. And it appears, they think, that it has molten rock, then water and ammonia, and then hydrogen and helium as an outer layer. Here we have a pretty impressive painting of William Herschel, the famous astronomer who discovered Uranus in 1781. This badass actually built his own A-frame, his own triangular stand to house and support a huge telescope in his backyard. That is awesome. All those pulleys and ladders to crawl up to the top. A little observation deck right there. He said, "I perceived the visible planetary disk as soon as I looked at it. His drive to examine the stars led him to build his own telescopes, among the best of his day, in the late 1700s. Wow, actually, right after the American Revolution. It's really interesting to put into context. from Saturn to Uranus will take 4.5 years. Across the solar system's mostly empty space, when we arrive and send radio messages back to Earth, the exchange of signals will take 2 hours and 45 minutes each way. Uranus is about 19 times Earth's distance from the Sun. Nearly 3 billion kilometers out from Uranus, we will look back at the Sun and see a tiny disk. But it's so bright that it's 1,000 times brighter than the full moon back home. By the time we reach Uranus, we will be barely halfway out of the solar system. Yeah, because remember this. This is the book itself is a long journey outward towards the stars. And it's being set up to be told as a narration in that context. If you're wondering why it sounds like we're being spoken to by a mission leader of our spaceship, we're being briefed. By the time we reach Uranus, we will be barely halfway out of the solar system. Behind us hang planets that took shape in the cloud of matter from which the Sun itself formed. But from here on, we may be touring different kind. But from here on, we may be touring a different kind of planet. Each perhaps a collection of millions of comets fused into an immense globe. Out here, says one theory, comets by the billions once orbited the infant Sun. Countless collisions built up Uranus and Neptune, whose gravitation then threw the remaining comets out to the farthest reaches of the solar system, and perhaps to other systems, such as the Oumuamua asteroid or comet was received by us recently. When we research or search the sky off towards the outer edge, we see a remote, dim world, Neptune. But this is a rare view. By the time we reach Uranus, it will be just overtaking Neptune. So the two will be nearly side by side for a few years, in fact. As Uranus speeds away from Neptune, Neptune will gradually fade from view and remain invisible for some 150 years. Then Uranus will once again slowly overtake its outer neighbor. Saturn is the outermost planet that we can easily see from Earth without a telescope. So people since ancient times had thought that Saturn marked the outer edge of the solar system. But on the night of March 13th, 1781 in England, William Herschel discovered a planet. He became the first person in recorded history to do so. Through a telescope, he was studying the constellation Gemini, and suddenly he noticed a strange star that seemed different from the others. He saw a disk rather than a star-like pinpoint of light. Over the next several nights, he noticed that the mysterious object moved across the background of the stars. He thought he had found a comet, but astronomers soon found that it moved in a nearly circular orbit beyond Saturn. Very unlikely behavior for a comet. And then finally, they agreed it was a planet. And since Uranus is twice Saturn's distance from the Sun, its discovery instantly doubled the reach of the solar system that people knew. And to the unaided eye, Uranus is a faint gleam. Even with modern telescopes, it's hard to make out the features of the planet. It turned out to be just another gas giant, though much smaller than Jupiter or Saturn. Its spin flattens the planet a bit at the poles and bulges it a bit at the equator, which is much the same as other planets. Uranus is a most unusual planet, though, because it's flopped over so that it lies on its side. As we speed towards the planet, we notice another oddity. Long after we would have expected to see evidence of a magnetic field, there's no sign of one. Then, suddenly, there is. A crackling of radio noise erupting in our receivers. The reason, as Voyager found, is that the bursts of radio waves from Uranus's magnetic field are much weaker than those of Jupiter or Saturn. Uranus's magnetic field is askew. The magnetic poles don't line up with the rotational poles as they do with the other planets, so they don't come out of the North and South Pole, even though it's leaning on its side. They're offset by 60 degrees, which is a little more than, I guess it would be more like this. So, if this was as it sits on its side, you would expect the magnetic fields to come out of the North Pole. So you would expect the magnetic fields to follow the line through it and go out of its north and enter into its South Pole, but they appear to be at 60 degrees coming out of its side. If that were so on Earth, our compasses would point to a north magnetic pole farther south than Los Angeles, California. Our spacecraft's computer tells us that on a certain date we will see Uranus cross in front of a star and briefly eclipse it. This type of eclipse is called an occultation, like the occult. Occultation. Astronomers studying Uranus during an occultation in 1977 were in for a surprise. 35 minutes before Uranus was due to eclipse the star, as we saw here. I don't know why they didn't use the word occultation here, but it's hard to whisper because it doesn't really sound like you think it would. So they saw the rings based on the dipping of the light intensity of the star. So after viewing multiple occultations, they recognized that it wasn't moons, but it was actually planetary rings that was obscuring the star passing behind, or the planet was obscuring the star as it passed in front of it. And they knew it wasn't moons because there was a symmetrical eclipsing and dimming of the star behind it, as it passed from over here. Them got blocked out and then emerged on the other side of the planet. So they found 9 rings they eventually count, but 11 main rings and perhaps many more thin or partial rings. So Voyager watched 2 star occultations, then sent signals to the Earth from behind the rings, so scientists could see an artificial occultation. It's pretty smart. Of the craft itself. Wait, let's see what it says up here. 7th planet of the solar system, Uranus hangs like a pearl against the inky sky. Voyager 2 took these photos in January 1986. About a week before the closest approach to the planet. Methane gives the atmosphere of Uranus its bluish, greenish color. That's so funny that it's made of methane gas. I always forgot that. A computer image turns the planet into a colored eyeball to bring out details in the polar region. Voyager's journey to within 80,000 kilometers of Uranus added 10 new moons to the 5 already known. And then here, this is the moon, Miranda. Strange as of Uranus's moons, it looks like a crazy quilt in this mosaic of pictures taken by Voyager 2 from about 35,000 kilometers away. The moon's cratered face is gashed with deep crevices, V-shaped cliffs, and wrinkled patches. Indicating a long and complex geologic history. Here's the South Pole. Here's an area of oval-shaped cliffs resembling a racetrack. Here's high, rugged plateaus. Impact crater 25 miles across. Canyon 10 kilometers deep. 25 kilometers across the crater is. The chevron-shaped area of deep grooves and winding cliffs, and the grooved terrain with long, narrow valleys on the right side here. And I guess here was ancient rolling hills with craters. That probably means it hasn't been touched, hasn't been violently reshaped geologically. I guess that's what the word ancient would mean in that context. So, they found that the rings are made mostly of big boulders, more than a meter wide. But instead of the icy coating that makes Saturn's rings shine so brightly, these rocks are black as coal. No wonder astronomers had trouble seeing the Uranus's rings. So what's Uranus like? As we close in on Uranus, we look down on a blue-green globe, about 15 times the mass of the Earth, but only 1/5 as dense. Methane in the upper atmosphere gives Uranus its color, but the murky air sunlight. The planet's temperatures are remarkably even. Uranus seems to transfer heat effectively from its poles to its equator. Like Jupiter and Saturn, Uranus gets hotter with the depth, as you delve into its atmosphere. If we plunge through its frigid outer atmosphere, we would probably splash into a deep sea of scalding water and ammonia over an Earth-sized core of rock and metal that's hotter than the surface of the sun, perhaps 7,000 degrees Celsius. Instead, we head outward to tour the rings and the moons. The rings are much narrower than those of Saturn, and they contain much less dust. If we could gather up all the boulders in all of Uranus's rings, it'd be a lot of dingleberries. Alright, I'm sorry guys, I couldn't resist. We would have much less material. We'd have less material than we could sweep up in just the tiny F ring system of Saturn. So A, B, C, D, E, F. The innermost of Uranus's rings begins about 11,000 kilometers above the planet and spreads out over a width of 2,500 kilometers. A gap nearly that width separates it from the next ring, and from there we pass the main rings in rapid succession, since most of them are only a few kilometers wide. The outermost, known as the Epsilon ring, is the widest at about 50 kilometers. By that time we reach its outer edge. By the time we get there, we're about 25,000 kilometers out from the planet, and at the rim of a great black wheel of rings, some 100,000 kilometers across, but only a tenth still of the span of Saturn's rings. You can see they get more dispersed, more sparse as you leave the planet, as you go away from the planet. Those marvelous moons. As with Saturn, the rings end about where the moons begin. Two shepherd moons, perhaps 40 kilometers in diameter, patrol the outermost ring. As they circle Uranus, they tug on the Epsilon ring, fraying it into patchy strands in dense areas less than 30 meters thick. In all, at least 10 small moons orbit Uranus, all of them discovered by Voyager. But the 5 big moons we can see from Earth are the most fascinating. And the smallest and innermost of these, Miranda, our moon right here, steals the show. It's only 485 kilometers wide, but Miranda is marked with craters, deep valleys that turn at right angles, ridges that look like racetracks, cliffs that plunge 10 times deeper than the Grand Canyon. Beyond Miranda, we pass Ariel, about 1,160 kilometers across, so almost 3 times as wide as Miranda. Ariel, on a surface crude with wide curving valleys and ragged canyons, we spot several familiar-looking scars, and they resemble the tracks of ancient glaciers back on Earth. Next comes Umbriel, somewhat larger than Ariel. It looks dark, ancient, oddly quiet compared to the jumbled surfaces of Scientists can't explain it, but its shape leads them to call it the fluorescent Cheerio. Oh man, this just keeps getting better. Now, Titania fills our viewports, the largest of Uranus's moons, at about 1,600 kilometers across. We see it as a splotchy sphere, split by long fissures that are edged in what looks like frost. Maybe it is. The cracks may have spewed out material that froze and fell alongside, a lot like this. Outermost of the moons, Oberon orbits some 583,000, half a million kilometers out from Uranus. It's nearly the size of Titania. I don't know what that is. Another moon like Titan. Maybe. A towering mountain thrusts up about 5 kilometers from a surface pocked with craters. Some craters look like they've once filled up with something liquid that has long since hardened. Much of Oberon's terrain is splotched and streaked with light material. All the major moons except dark Umbriel have shown us those whitish markings, and all except Umbriel showed terrain apparently pulled and squeezed by the powerful forces sometime in the past. The best guess is that the planet's gravity was responsible for the geologic features we see on these moons. Why not Umbriel too, then? We might land and try to unravel the riddle, but we have another planet to visit. So now, guys, after we've done Jupiter, Saturn, Uranus, we've arrived at the last of the gas giants, mighty Neptune. And I promise I won't make you wait as long in between planetary voyages next time. But we'll leave it there for tonight. I thank you. Appreciate you watching. I thank all my supporters, everybody who comments, and everyone who let me know that space is your preferred topic to drift off to and relax, listening and learning about. A lot of you love history as well, but I really think that the majority of you, like myself, are particularly pulled towards topics of space. It's too cool. So we'll keep it up, and I'll try not to leave you in such a spatial, astronomical drought next time. I'll try to be more consistent with these episodes. As always, I want you guys to sleep well, and thank you for all your support. Thanks for all your feedback, and just thanks for watching. It really means a lot. Get some sleep, guys. Happy holidays, and we'll see you